Today we're going to be talking about a simple equation, which is V equals IR, where V is voltage, I is current, and R is resistance. Shoot, it's supposed to be CE. So, let me draw a little diagram here. We have a resistor. Now, this is a very, very simple analogy. We're going to say that our resistance is equal to 100 ohms, and we have a voltage applied across this resistor, which equals 10 volts. Now, you may be asked, what is the current I? So we have V equals IR, where V is 10 volts. We're looking for I, and R is 100 ohms. So I is equal to 1/10 of an amp. Now let's look at a bit more complicated equation. So we'll have our voltage source attached to a resistor, which is attached to another resistor in parallel. So we'll call this one R1, and R2. I'm going to say that V is equal to 10 volts, make it real simple. R1 is equal to, let's say 20 ohms, and R2 is equal to 10 ohms. So a few things to note here is this intersection has a certain voltage, and that voltage is V, right? Because there's no resistance anywhere in this line. And then we have this intersection here, which is still just the same line, which is also V. So we have plus, should do that in a different color, plus, minus, plus, minus. This minus here is the same minus here. So this is all grounded. And grounded just means a potential of 0, so 0 volts. So what I can say is find the current going through the voltage source, I. There's a couple ways to do this, and I'm going to show you both ways and show that they're equal. So you can take, let's say, I1, and there's I2, and you can say that I is equal to I1 plus I2. You could also say that V is equal to IR, where R is equal to the summation, it's not directly equal to, but the summation of R1 plus R2. Let's do a first example. So we have R1 is equal to 20 ohms, R2 is equal to 10 ohms, V is equal to 10 volts, I1 is equal to, remember it's V equals IR, so it's 10 volts divided by 20 ohms, which is equal to a half an amp, and I2 is equal to 10 volts, because it's the same potential across that resistor, divided by 10 ohms, because that's the resistor in that branch. So that would be 1 amp. So we have I is equal to I1 plus I2, which is equal to a half amp plus 1 amp, which is equal to 1.5 amps. Now using the other method, if we have two resistors in parallel, we can equivalate them to one resistor. But because they're in parallel, you have to say that 1 over R1 plus 1 over R2 is equal to 1 over R, where R is the equivalence of both resistors. So we can say, okay, well, 1 over 20 plus 1 over 10 is equal to 1 over R, which is equal to 3 over 20. So R is equal to 20 over 3. Then always say is V equals I R, where R is our total resistance. So the voltage going across is 10 volts, and our resistance is 20 over 3, which is equal to I. So I is equal to 30 over 20, which is equal to 1.5 amps.